Okay, hello. So I want to show you the stuff I've been working on for the next major release of Cerebral. There are a couple of highlights here, and there's tons of updates to um, more API consistency and more stuff in the debugger. But yeah, I'm going to show a couple of things. So I have the To-Dos app open here, and if I jump into the debugger, we can see that we have the traditional stuff. We have the signals, we have the state of the application, and we have the history. But now we also have this new tab called state effects. And what state effects shows us is what state is being watched by the application and what depends on this state. So if we take the third one here first, which points to state to-dos, and the double asterisk there means that it is interested in all changes beneath the to-dos path, we can see that we have one computed called count that is interested in this state. And then we can go to computed counts, and we can see that there's one view, which is the app, that actually depends on this computed. So when the to-dos update, it updates the counts update, and it updates this app view. And then we have state new to-do title, which is depended on directly by this new to-do component. So let's have a look and see when I change the code here. Hello. We move back into the debugger, and we can see that there have been 5 updates. And if we look into these changes, we can see that, okay, we changed the new to-do title, and whatever was watching state that was affected by this was this new to-do component. The green indication here means that you will get like a performance indication. So if you have a lot of watchers, for example, you might get into, like, it's not concrete, like performance is very hard to measure in an application, but it might give you an indication that maybe you should refactor or whatever. It also states how many changes was batched for this specific update, and then like a summary of what kind of watchers were affected by this change. So if I move back and I hit enter, we can see that now there were actually 2 state changes that were batched together, which was a new to-do and also the new to-do title. It was emptied. And we can see that the new to-do was affected by this, and the counts was affected by this. Okay, what I also want to show you is that when I go to the history now, we can actually see how things were affected. Actually, I can see there's a bug here. I have to fix this because it changed the view twice. It might be the change filter. Yeah, because the messages to the debugger is being debounced. So we have to make sure that things are in the correct order here. Anyways, what you will typically see here in the history is whatever state changes was made, and you will then see chronologically what watchers were affected. So here you typically see change new to-do title, the to-do view, new to-do view was affected by it. And the same again, we changed the state and the view was affected. And when we submit the new to-do, we can see that there was a computed of counts and a view of new to-do that was affected by this. So that's pretty cool. So let's dive into the code here. What's kind of interesting about Cerebral in the new major version is that when you connect, you can actually just connect directly to a component. You don't have to explicitly state the dependencies. You can just connect directly to the component. And all components that are connected will have this get injected into them. And you use this get property, which is a function, and you call it and you pass it what we call a proxy. Now a proxy basically just converts this pointer here into something Cerebral understands to go and grab in this case, the computed. Or you might use state here, or you might use signals to go and grab stuff. I can show an example of that. The point is that this happens as the component updates. So what's really nice about this is that it will, you don't have to be explicit about the state dependencies. It will automatically, based on the rendering of the component, it will optimize the next rendering based on what state you actually grabbed during the rendering. Like, it does have an overhead because it needs to keep track of these dynamic dependencies, but again, it optimizes because you only watch what you need to watch for the specific render, which is kind of nice. So I would state that if you have full control and you like explicitness, you would still define the dependencies up front. But if you're writing like not a huge application and you just want to get going, you can do it like this. Okay, so let's look at another component. Here we can see the footer. We go and grab the filter, we go and grab a computed, and we go and grab signals here. And then we use it inside the component. Okay, so that's the one thing I wanted to show, and then I'm going to stop this process, and we're going to... Oh, sorry, I was actually running the one I wanted to show you, because I want to jump into the TypeScript version of this. So in the TypeScript version, we have, let's see, we have this thing called the Cerebral proxy file. And what this does is basically just expose all the types of your application. Here we can see we have the app state, the app computed, the app signals, and the app providers. And then we expose a context for our actions. And we're also using the chain sequence API to define our signals. And then we expose our proxies, but with types instead. So let's see how this looks. So when I connect now, I'm explicit about my dependencies. I don't have to. I could use the same approach as I showed earlier. But I just wanted to show you how this works as well. So now this computed is grabbed from Cerebral proxy, and it's actually typed. So when I have my counts here, we can see the type of counts, and we get that into the component as well. And yeah, everything works as you would expect. And we can have a look at the footer as well, where we also go and we grab the signals, like a couple of different signals, and we get that into the component as expected. So this is just explicitly stating the dependencies, and everything is typed here, which is really nice. It's not much to it. The way you would type, so you type your modules, because the modules contains everything. You just type the state as you would type anything in TypeScript, and then it's possible to use this signature to type your computed and type your signals. What's really nice about this is when you create new signals and you create new computeds, you can just create them, and they will be available for all the components and everything. So what we can see here is, for example, filter clicked. We can see that this needs to be called with the filter property, which is a string. So if I added a new signal here, it will be typed on signals, and I could just start using it right away. So it's a really nice, cool thing. And again, yeah, as you saw, the debugger works as expected, and you also see how many times the different watchers has run and all this good stuff. This last symbol here, that is called a reaction. So let me just show you quickly here. We also get something called a reaction in here. And typically you would create a reaction when the component mounts. And a reaction is just the same thing like as a computed, you would say foo state. Oh, you can do computed. Let's say computed counts, for example, or is all checked. And then we get callback here, which receives the foo. And what this thing does is, oh yeah, you have to give it a name as well, my reaction. So what this allows you to do, and you also get the get here. So what this allows you to do is create reactions inside your views. So for example, maybe you have some kind of library you want to do some imperative logic on. You can just create a reaction where you point to some state or computed you want to trigger this reaction. And then you could, for example, grab a signal, or you could say this mylib do this, for example, inside a component. These reactions can also be added directly to the module. So you can have like reactions, my reaction, and then create a reaction like this, which does exactly the same thing. Cool. Okay, I think that's enough for now. I will of course create like a full overview of all the changes and migration guides and all that stuff, but I hope this gets you at least partly excited about the changes. So yeah, talk to you later.